The third question here says, an electric dipole is placed at an angle of 30 degrees with an electric field of intensity 2 × 10 raised to 5 Newton per Coulomb. It experiences a torque equal to 4 Newton meters. The charge on the dipole of dipole length 2 cm is. Now we are given the dipole length and we are given the intensity of the electric field in the region, and we know the angle that the dipole makes with the electric field, and we know the torque experienced by the dipole. Based on that, we should find out the charge on the dipole. Now, please consider a uniform electric field here in this region, which is represented by equidistant parallel electric field lines, and E vector represents the electric field intensity in that region. Now, a dipole is placed here with negative Q charge here at one end and plus Q charge at the other end, and the dipole makes an angle 30 degrees with the electric field in that region, and P vector will be the dipole moment vector, electric dipole moment vector of this dipole, which is in the direction marked from the negative side to the positive side, or from the negative charge to the positive charge. Now, you know that the dipole here will experience a torque, tau vector, which is equal to P vector cross E vector, where P vector is the electric dipole moment vector and E vector is the electric field intensity vector in that region. The magnitude of the torque, tau, will be equal to Pe sine theta, which simply is the magnitude of P vector cross E vector. Now, the magnitude of the torque is given in the question as 4 Newton meters. P, or the magnitude of the electric dipole moment vector, we are still yet to find it out, and that is unknown still because we only know the dipole length. We still do not know the charge that we have to find out. So we'll just keep P intact, and then we have E, which is given in the question as 2 × 10 raised to 5, and sine theta will be sine 30, which is 1 by 2. We are avoiding the units here because everything in this equation is given in SI units, so the answer will be in SI units as well. Now, we'll strike off 2 from the numerator and the denominator, and then we have P is equal to 4 × 10 raised to minus 5. On rearranging this expression here, what remains after cancelling off 2 from the numerator and the denominator. Now, P, the magnitude of electric dipole moment vector, is equal to 2qa. And A is the half separation between the point charges on a dipole. So 2a is the separation between the charges on the dipole, and q is either one charge. So we can say that P can also be written as q into dipole length. 2a is simply the dipole length. Now, that means P, which is equal to 4 × 10 raised to minus 5, will be equal to Q, which is the charge on the dipole that we need to find out, multiplied with the length of the dipole, which is 2 centimeters, which when we write in meters would be 2 × 10 raised to minus 2. Now, in that case, Q will be equal to 4 × 10 raised to minus 5 divided by 2 × 10 raised to minus 2, which will be equal to 2 × 10 raised to minus 3 coulombs, which is the SI unit for charge. We have taken everything in SI units here in this expression. Now, 2 millicoulomb will then be the answer, and the correct option will be option C, 2 millicoulombs. That's how we solve it.